We will continue discussion on the storage pool design today. I think last time we talked about that we want to explore how to do spreading, building on top of what Patrick is proposing. So, so I thought about that. I can share that. But before that, I know that Patrick, you have updated. Did you update the cap, or you put some idea there? You have some suggestion.
No,
should we talk about that first?
We can talk about the idea. It's just a proposal at this time. I've not added the cap itself. Let me see whether I can find my comment. So the basic underlying proposal was that because we are currently really stuck on this question of what is a storage pool, do we want to expose it in the cluster? And that this controversy is holding back the merging of this cap and the continuing with the work on just the storage capacity issue. My proposal was that I remove basically the pool concept, the pool definition from my API proposal, and otherwise just keep the structure as it is. So we currently have as a top level object in the cap the CSI storage pool object, and then some data inside that which describes capacity in a certain topology for certain storage classes. My proposal is to avoid the controversy that I just rename that API object to CSI storage capacity. And that's good enough as alpha for the purpose of this cap. It's perfectly sufficient. And then in parallel with me doing some implementation work, we can continue at a more leisurely pace around what other things may have to be in that top level object, whether we want to call it CSI storage pool. And if that turns out to be a valid use case, then we'll probably just rename the whole thing again to CSI storage pool. That is the rough proposal.
I think that seems like a reasonable way forward as long as we keep a one-to-one mapping between those two objects. I do want to say one thing, taking a step back, you know, I realize how frustrating this can be for everybody involved. I think a lot of people have a lot of really great ideas here. And when we started on the Kubernetes volume storage subsystem, I think a lot of the problems that we had were not quite as challenging because we weren't trying to handle quite the complexity and quite the number of use cases. And so I think what happened is all the low-hanging fruit is gone, and all the problems that we have left are the really hard, complicated ones. So the only thing I wanted to add was let's be patient. I apologize that this takes so long, but the goal is to try and get this right. We want this to work not just for any one of us. We want it to work for all of us and be kind of the best interface that it can be for all of our users. That said, back to you, Patrick.
Yeah, so that's a proposal. I got positive feedback from Saad. Qing, what do you think? Is that something that you can live with?
I thought your last proposal was actually not to change the structure, right? So, but just rename it.
Yeah, the structure.
But I think Saad is
that's correct.
Yeah, but Saad's proposal is making it a one-on-one mapping, so it's still sort of different from your proposal. I know you proposed the one-on-one mapping first, and then there was another second proposal, which is to keep the existing structure, everything unchanged except for the name, right? That's your last proposal. So I think for that we still have a little.
Yeah, let me share. Let me share my screen then.
Okay.
So where is the sharing button there? So the proposal that I just proposed is this CSI storage capacity. And
So you basically
the
rename
structure,
CSI storage pool to CSI storage capacity, right?
Yes,
That's the only change, isn't that's correct, right?
And
yeah,
yes, that's the only change. The
right.
other
So I think
proposal, let me go back, see whether I can find that. This was somewhere with
that's different
Michelle.
from, I think Saad is talking about the one-on-one mapping, which was what you proposed earlier. I think there was another version
No,
that you.
I'm not sure. Let's see whether I can. So that is the other CSI storage capacity, which has a different structure. So that's a flat structure with more objects. No topology, storage class name, and capacity are basically in that object. And whenever something is different, we have different objects. So is that the structure that you want to have as an API object?
Yeah, I'm not so much concerned about the name of it as much as whether it's a one-to-one mapping, one-to-n mapping, or n-to-one mapping between storage class and whatever we're calling the other object.
Okay, so basically, so basically every time we create this, yes, you don't like the name, but yeah, we put that aside for now. So every time you create this, so this one contains the node topology, storage class name, capacity, but you could potentially have another CSS storage capacity that has the same storage class name, but maybe with a different capacity, right? That's still possible,
Well,
right?
right? So that's technically that's possible. So I don't like that flat structure. The one that I'm highlighting here, I think, is problematic. So constructing these objects, we will have a lot more of these objects. My expectation, and that's just a guesstimate at this time, is that the load onto the API server will be higher if we use this approach. So purely from a technical perspective, I think this is the worst solution, the worst approach for storing this data. And that's really about all that it comes down to at this point. Which way of representing this information is more manageable for the API server, right? We're not concerned about concepts anymore. We are now trying to find a good representation, right? Or what other concerns do we have if CSI storage capacity, if the struct looks different?
So this is the API, right? It's not just the struct. Is it just the struct, not the API
well,
anymore?
Yeah, it is an API. The structure is not complete, so it would have normal object metadata. We may have. I think the CSI driver name is missing, so it would have CSI storage capacity spec with just the name because that's the only invariant. Topology, well, and storage class name probably would be also in the spec. So whenever that changes, we would remove or modify the things. Topology, well, I don't know. We can debate whether that goes all into status or spec. But my concern really is that this is technically not the best representation. I know there were concerns about having too complex objects, and in particular when they get updated by multiple different entities, because that's problematic. But that concept doesn't apply here because there is just one producer of these objects. And they most likely will have to iterate. Right?
Sorry, I was thinking, so this would be kind of a stepping stone. It wouldn't be permanent. Ideally, if we end up with a one-to-one mapping between storage class and this, we can extend the storage class object in the future if this proves viable.
But there is no one-to-one mapping storage class and topology. That is one of the issues that we have, that if you have a storage class that says, give me persistent memory, my favorite example because that's what I'm working on, then there are different topologies for that. One per node. It's a node local storage. You can't just have one storage class per node. That just wouldn't scale. It wouldn't work for the applications.
Right, but I thought we went over this. I thought the solution there was to have one storage class per tier and assume that it will be across multiple topologies, and the topology is not computed until provision time.
So, Saad, can I ask why it's such a big deal, the one-to-one mapping for you? What's the benefit?
I think what I'm trying to do is contain the API growth. What is the problem that we're trying to solve is kind of what I'm getting at. And so I think last time we had a meeting, we talked about cluster topology, volume accessibility and availability is one issue. That made sense to me. We talked about capacity, intelligent capacity handling, and that made sense to me. And so I want to add minimal API to enable those use cases.
Yeah.
And so if we're going to do a one-to-n mapping, I want to understand what the use case is that we're trying to solve. Yeah. It sounds like there may be a possible use case based on storage topology, but we're not certain about that.
Yeah. So the last time we talked about placement, and that's where we kind of assumed that perhaps a storage class representation of the different availability classes may work. For local storage, I'm adamant this just doesn't work. For the applications, we want to have one storage class that they can select in their PVC, and they don't care where the storage is, as long as it has this one key attribute that it is persistent memory. And then the system is supposed to find one node that has sufficient capacity left to create a volume of the pod and create that volume there. And we therefore have one storage class and n different topologies with different capacity, and we need to represent that.
Yeah, I'm kind of with Patrick here. I don't see how the keeping it one-to-one would let you solve the problem of helping the Kubernetes scheduler know which nodes are acceptable.
I think it's not this part that we're concerned about, the mapping. It's the fact that can you share, when we had a single pool object with multiple storage classes, then the question came up is, can multiple storage classes share the same pool? What does the pool capacity of the pool actually mean then? And a lot of other sort of orthogonal there came up.
I wonder if we should. I wonder if we should look at what I'm trying to do with this spreading. Trying to explore that using volume group. Should we take a look at that and come back to this?
I don't think that will help because I don't think that'll help. So,
sorry, I just want to share some thoughts
to address this. Yeah.
Sorry. So I'm also, I'm going to keep basically trying to understand having the scheduler also goes through the storage class, and then it need to find the node in which it can provide the storage. So I think one-to-one mapping sounds good, and also it helps users to understand the SREs, basically to see that, okay, this is a storage class and this is a topology, and each having what storage with it. I think that's...
Yeah, but that's one-to-end. That's one-to-end. You don't have, for certain classes of storage, for the non-network attached storage, where we basically have one giant pool for all nodes, you don't have just one topology. The question just came out whether multiple storage classes can share the same pool, and that's also true. We also have a situation where one storage class has different parameters.
So I agree that you need an object per topology, but I think where the complication is if you have if that single object has multiple storage classes in it, I'm not sure the value of that, because the capacity we report is going to be not accurate already. So I'm not sure why having that sort of mapping really adds value.
That's true. So in
that's my argument.
So in the
my argument here is,
sorry, for one-to-one mapping thing, in the above structure, the storage class name, and we have one storage, the capacity thing. So topology and capacity can go in an array of struct. I mean, topology and capacity in a struct, and then array of them should make you like one-to-one mapping between a storage class and then per topology, what is the capacity you have. I also see that if you, for a user looking at from SRE angle, what is the storage class and where is my storage available and where it can easily come the volume. So that actually makes sense.
But if I just look at the get capacity RPC in CSI, I don't think that is the one-on-one mapping. I mean, for each get capacity, you do have the volume capability, you have a topology, then you have a this parameters, which is supposedly storage class, right? But that's just saying like, you know, these two together, you return this capability.
Yes,
you
so I
return
think
this capacity.
basically this API here, where it's flattened, I think that API matches better with how it's represented in the CSI spec. Because in the CSI spec, it's
Okay.
capacity
Yeah,
per
I think,
topology per storage class.
So
yeah,
I worry about
So
I worry about setting the bar so high that we assume that the capacity is always perfectly accurate. I mean, there's going to be situations where
we don't.
perhaps multiple storage classes share a capacity and you consume from one and it actually ends up also consuming from the other one, and that, depending on how racy the system is, could result in bad decisions being made. But you're always going to have races in your capacity information. You're always going to have situations
that's
where.
Why this cap.
Go ahead.
That's why you need to combine this cap here. This is why this cap here needs to be complemented by other caps that deal with the situations where the race goes wrong. That's why we fixed, for example, pod rescheduling and yeah. So
I think we need to set our standards such that like the capacity is a useful hint that will usually result in making the right decision, but accept that there's a lot of situations where it's going to result in a suboptimal decision, and you need to be able to recover from those. To say that it's not acceptable for it to ever be wrong is that it sets the bar too high.
Yeah, I think we all agree on that. That's not the controversial part. I just well, okay, I can implement the whole thing with this flat structure, and if that's what's needed to get it accepted, I will. My concern is just that performance will be worse than it could be otherwise. But if that is something that we can come back then later, perhaps if we have some benchmarks or so, okay, I'll take what I get and could go ahead with a cap with that flat structure if that's the only thing that we can agree on.
Okay, so is the only concern around performance then?
For me, it's twofold. One is performance. The other is if we end up deciding that storage pools as a concept are useful, then this flat structure is the wrong one.
Okay.
Then we may have other future arguments that require reintroducing what is currently called CSI storage pool in this cap. But then we'll have written already a lot of code that assumes this flattened objects, and we'll basically have to redo code. But okay, that's.
I think my main concern is that, like, I don't know if we should introduce a first-class concept of storage pool without CSI having a first-class concept of storage pool.
So I'm actually propose that we add that. I actually explore that when I'm looking at how to do spreading. We can talk about that after we are done here.
Yeah, but the question is, do we want to? It means a new CSI API with all the delays that this causes. Can we first reach some agreement on how to proceed with this cap for 119? Because I think that's crucial.
Yeah, that's fair.
Do we agree that the CSI storage capacity, one that I've highlighted now with just all of these three values replicated in each object, is that something that we can implement for 119?
Michelle,
then I'll change the
Yangqing,
cap
do you have
accordingly.
any?
Can you rename it? I mean, it's a storage capacity. I was feeling pretty lost with that name. Can we name it like CSS storage placement or something? Make it like
We can
more than
placement.
just
like
capacity?
discuss the name in an implementation PR.
Okay.
But kind of the structure or high level direction here, does anybody have a major objection to, knowing that this would be an alpha and we can iterate on it and change it? But just to unblock Patrick, does anybody have an objection towards this approach as a stepping stone?
I think I'm fine with moving forward with this. I just want to say that, but before we move from alpha to beta, I want to make sure that we get this other spreading problem resolved and figure out whether we need to have a storage pool in CSI or not. So we need to figure that out before we move to beta, I think.
I think that seems reasonable. So maybe what we can do is unblock Patrick here. He can start implementation for 119. In parallel, we can continue the discussion around placement and come up with a design, hopefully by the end of quarter for that. And then for the next implementation, whether that's next quarter or possibly if it takes longer, the quarter after that, we can merge both of these into a single beta implementation.
Yeah, sounds good.
Okay, I can start with implementation work, but I also need the cap accepted, and I think I need to tell him that indeed planning to put something into 119. So for the enhancement issues, I also have been holding back with a confirmation that this is for 119, but I think both the storage capacity cap and the generic inline volumes that Jan reviewed today, I think those two will be scheduled for 119, right? I can go ahead with that conclusion.
So are these two not really dependent on each other, right? So I added a comment there saying that can we separate them more? I mean, it's right now it's that one is kind of in this and
no, they are separate. Well, this one here refers to inline volumes. I think with a decision to move forward with generic inline volumes, I will update the capacity.
Yeah, so I was wondering if you can
that the other will go in.
So can you for this cap, can you remove most of the discussions about the inline volume thing and maybe just like one line as a reference saying this is in the other cap? Because otherwise I found it's very confusing to read. Okay, yeah, I think that would be more, then this will be more focused.
I can do that now that we have reached a decision about inline volumes. If we hadn't decided to go down that path with generic inline volumes, it would have to be in this cap because it would have meant extending inline volumes and having this other field that needs special support in the scheduler. But now that we don't do that, yeah, I can take out that part.
Okay, thanks.
So since we have 30 minutes left, maybe let's use this as a time to review this cap and get a head start on that. Do you want to just go through it line by line or object by object and talk about what the proposal is?
We've done that a few times and it's not up to date now as it stands because it does still have the other. But yeah, if that helps, we can do that.
That's okay. If it's not up to date, we can do it offline. So
I do have something for the spreading. Do we want to look at that? I was planning to do that, but I don't know. I don't want to derail what Patrick's trying to get into this cap. So
no.
We do still have 30 minutes.
If I can get if I can get Michelle to actually look at this or Saad, I don't know who's now marked as the reviewer. Well, I think it's Saad at the moment, but Michelle was actually the one who
I think both Saad and I signed up for reviewing this. I'll be reviewing this one too.
Okay, good. So if we can get the review done inline after I've done the agreed upon modifications, say this week, then we're fine.
And so does inline also need to be approved and implemented this quarter, or can it wait? Do we just need a design this quarter?
I would prefer I would prefer to get it into implementation.
Okay. And
Just
how's that
more.
looking in terms of who's been looking at it?
Jan
I am
looked at
looking at
it.
it, and
Yeah.
it looks actually pretty good. I still struggle with the naming of the fields in volume source, but I think that's the only open issue, and we can solve it during API review.
Okay. Could we go over that, Kep, right now? Just because these two are related and we want to unblock them for implementation?
We can.
And Xing, I think the reason I'm holding off on the placement one is because it's not going to implementation this quarter.
Yeah,
We
that's
have to
fine. Yeah, I
review it.
know the deadline for cap freeze is next Tuesday, so yeah.
Yep.
Reasonable. Yeah.
So this is the description of the idea that we deal with the more complex variant of inline volumes, those that are actually provided by mostly a traditional CSI driver, one that needs to provision volumes where provisioning isn't a lightweight local operation. And we want all the usual features that we have with persistent volumes and CSI also available for inline volumes. That's the motivation. We could get there from bottom up by extending what is called CSI ephemeral inline volumes, but I think that is not going to get us all the way, and it's going to be horrendously complex with different code paths for the same thing for normal volumes and CSI inline volumes. Therefore, the proposal here is to do something to achieve the same goals where a pod spec can specify a volume inline. That's one key part. The other is that it's still an ephemeral volume, so it's mostly just this one pod that will use the volume. But in contrast to CSI ephemeral inline volumes, it's a work with a normal unmodified storage drivers. No special logic in the code, no special deployment things necessary for it. And also just the usual code paths in Kubernetes, all code for the actual provisioning in Kubernetes. And then the key part that triggered all of that is we would get storage capacity tracking, the other cap, also for these kinds of inline volumes, because right now for CSI inline volumes, those are assumed to not have capacity to be provisioned on any node. And we want that to the storage capacity tracking also work for these other kind of inline volumes. It's not a replacement simply because the overhead will be there for the more heavyweight provisioning process. So we need both in the future.
Why do we need both?
Because one of the design goals for CSI ephemeral inline volumes was that these are easy to provision and quickly provision for a large number of pods. For the secret injection, for example,
okay.
It probably won't make sense to use for more heavyweight process suggested here in this cap for those classes of CSI drivers, but only for those CSI drivers. So the original design goal of having something where the CSI driver gets written just for this one purpose of ephemeral inline volumes, that remains valid. And I think the current solution is appropriate for that. It's just different goals.
Okay. Just right off the bat, I think having two ways of doing ephemeral, we should think about how we're going to expose that. I guess end users aren't going to care because they consume it in the same way. The only difference will be in the driver implementation side.
Well, the API is different. Well,
I think you will have to, users will have to know which driver supports which mode.
Yeah.
What is that going to look like to the end user? How are they gonna...
That's the proposal. Yeah. So the current, do have for CSI inline volumes, we do have a CSI volume source, which is basically just driver name plus parameters. And for the new inline volumes, we will have something where Jan has already pointed out that the name might not be perfect. We will have an inline volume source, and that gets embedded inside the larger volume source as another optional pointer. So the volume may be provided by this volume source here. Then if that is what's providing the volume in the pod, we need a new controller, and we agreed that this most likely needs to go into the Kube controller manager, which looks for pods with such a volume source. And when it sees one, it creates a PVC inside the namespace as the pod. That's conceptually the same as what the stateful set controller does, except that we now apply it one level below for pods.
So I have I'm just brainstorming here, so this might be a stupid idea. Is there any way that we can keep the existing inline CSI API and also implement this? And the way that I'm imagining it is you could have driver opt into this behavior and say, I support it. And then you only add additional fields to the existing API, that the minimal number of fields that this needs. So something like the size of the volume, the capacity, or sorry, the size of the volume. And so if a user specifies in the existing API the size of the volume field, then we interpret that they want this functionality, and then we automatically construct the volume claim template if the driver says they support it.
There are many things that would be missing, like the storage class. So you will basically end up with putting everything that is currently in a persistent volume claim in the spec of one into the CSI volume source, and you basically ignore the other fields. So you would end up with one CSI volume source that can contain either one or the other. Not sure whether that is a good API, to be honest.
Okay. And so the other things that we're going to need there is a full storage class, is the argument.
Yeah, well, you basically want to be able to construct a full persistent volume claim, and therefore any information that goes into that needs to be in that volume source too, because otherwise the user will have less functionality available to him when going through that route.
And that would include,
that
would include like topology, that would include access mode, that would include capacity.
Yeah, everything basically. That's why I even have a full persistent volume claim here and not some simpler object, because that is the structure that contains all the information that the controller will need.
Yep.
It might be a bit too much. Strictly speaking, for example, the persistent volume claim spec may be enough, but then what do we do with labels? That's the piece of information that currently would have to be constructed somehow.
I would compare it to stateful set.
Yeah, and but stateful set uses exactly that. It embeds a persistent volume claim. That's my that was my initial approach. Make it like stateful set. Whether that is a good or bad thing, I don't know, but it's what we currently have, so it's consistent.
From a technical aspect, we might need to check with API machinery on whether or not it's possible to embed a template in a template, because pod spec is used as a template. So there might be some technical challenges with embedding another template within that.
But stateful set does that. So I don't see.
No, stateful set is one level out.
I can imagine then that a stateful set could have some ephemeral volume, and also it could have a stateful volume that survives the pod. Like both has its uses, and I don't see issue.
Yes, I agree.
No, I don't see issue with
I think I don't see a conceptual issue with it. I'm just saying there might be a technical limitation of it, because I think there are some problems with the current like pod template, And I'm not sure if those problems will be exasperated with having another template within a pod template.
But persistent volume claim is not, it's just a structure. Why should, it's called a template because in parallel to what it's called in the stateful set, but the actual structure is the persistent volume claim. Okay, well, I guess if that turns out to be an implementation problem, we can make the type simpler by, for example, replacing it with a persistent volume claim spec or individual fields. But this here is what I would try to implement first. And if that works, I would stick with it. It's simply for consistency and because it's generic. If, for example,
Sure.
if things
I'm
get
just
added,
saying that
yeah.
I'm just saying that I think we need to work with API machinery to just understand the mechanics of this and make sure, like the API mechanics, and make sure that this is actually feasibly possible.
Okay. Yeah, I can ask them whether they see it no problem.
What I would suggest to put an example of a real pod into the cap, how it looks like, so someone understands and also the API machinery sees how it looks like, and then ask them for feedback.
Yeah, okay. I can do that. Do we want to talk naming a bit here, or do we, well, rather not? Okay, well, I'm not sure. Naming is always hard. So the inline volume source, as Jan said, is a bad name, or it's confusing because other volumes are also inline.
Yeah, I think
my other proposal was claim volume source, because that's what it really does. It creates a claim and it's provisioned through that claim. Or if we want to be even more correct but sound worse, in my opinion, is volume claim volume source. So I'm now taking votes, essentially. Not sure whether there's a better way to come up with something that everyone likes.
I have a question. How in the cap you say that it may be extended to make the volume persistent.
Yeah.
How real use case is it?
I don't know, to be honest. It might be useful for, I don't know, some higher level controller which may want to do things with the result of what the pod produced at runtime. I'm completely making this up now. I don't have any real use case for it. I just want to avoid the situation where by choosing a too specific name, we prevent us from implementing something that later on may turn out to be useful. That's really all.
Because to me, the volume is basically a smarter emptier. Instead of using the root disk, I can use whatever storage I have in my cluster instead of emptier. And of course, I can use like volume snapshot as source of the claim or growing a volume, but it will just live as long as the pod is living. So if we could call it a scratch space or generic emptier or something like that.
Yeah, but it doesn't even have to be empty. That was
I know you can have snapshots and other smart stuff, but
so empty in the name would again go or would imply something that's not necessarily true.
Can we use ephemeral? Because I think the key here is
that's what I didn't like, because it's currently ephemeral, but that is not necessarily, it's almost an implementation detail that would be very easy to change. And if we ever come up with a use case where we don't want it to be ephemeral volume source would be the wrong name.
Isn't that the whole point of this? Am I missing something? Isn't it that
the life cycle?
It is currently ephemeral because that is most likely the most useful thing to do with it. But the inline part, that is what's triggering it, and ephemeral, in my opinion, might go away at some point. It's just a possibility. it would be a pod spec like this one here, inline volume source. There would be another field that says ephemeral false, and then the controller will simply skip setting the ownership relationship. And then when the pod terminates, that PVC continues to exist with that deterministic name, and someone else will need to clean up or do something with it. So technically, that would be very easy to implement if there is someone who takes care of that orphaned PVC, or if does something with a PVC. If that isn't the case, then this mode doesn't make sense.
I'm not sure what that mode will buy us compared to the current PVC flow.
That may be true, actually. It might.
Would it
I'm not.
buy you
Yeah.
the deterministic naming associated with a given pod?
You do get that. You get some more structure around how those PVCs get created, but as it, yeah, because it assumes that there is some other entity managing the PVC, that entity might as well deal with PVC creation. Okay, so I guess I'm fine retracting my objection, and we can just call it ephemeral volume source.
I am fine with that.
Okay.
What about the life cycle of related objects, like if someone took a snapshot?
That's still racy in the sense that, well, if someone triggers a PVC snapshot and deletes the pod, then deletion of a PVC will be triggered. But that's not different from other cases where a snapshot gets created and then the PVC object gets deleted directly.
So I guess basically what this is only going to handle the life cycle of the PVC if there were orthogonal objects created that are related to the PVC, like volume snapshot, we're not going to automatically clean those up when the pod terminates.
No, this proposal will only know about this one PVC that gets created for the inline volume and nothing else. And even deleting will not be done by the controller. It will be handled by the pod, by the ownership relationship and by the APA cipher when it cleans up orphaned objects.
Does this work with resize?
I don't see why not, because the controller itself, it will just do the initial creation. That is necessary to set the ownership relationship. It can't be done by some higher level object, or some higher level controller, because they don't know in advance what the UID of a pod will be. But the controller, if it reacts to an existing pod object, can set that ownership relationship immediately when it creates the PVC. And of course, and we get the other components also to deal with that inline spec. The resizing then needs to happen by someone modifying that created PVC. It's not through the embedded volume source and through the special controller, and intentionally, so it keeps the implementation of this controller very simple. It also is not currently possible to modify anything in a pod spec other than some very selected fields. In particular, the entire volumes array is read-only or create-only. It can't be modified technically. The API server prevents that. So even if we wanted to modify this inline volume spec, we couldn't do that at the moment.
But
so
if
yeah,
you have a PVC object, right? You curate, you will still be able to find this PVC object. You can do a
and then
kubectl edit, right? It's still possible.
Yeah, of course. That's why all the other things that you can do with a PVC will then just work normally. There is a PVC object. You need to know, of course, that it can go away, but that's not different from other use cases. So, yeah. That's what I like about this approach. All of the other things that you may want to do with inline volumes suddenly become very easy to do because we do have the PVC object as something to hang them on.
Yeah, it makes it composable. Instead of having to redo everything for ephemeral volumes, we can reuse the existing infrastructure. That is very attractive.
Yeah.
I think the only major concern I have is around API usability. If we can come up with a way to minimize the confusion to end users. So I like the name, just sticking ephemeral in the name, because that makes it very clear what the purpose is. But the existing CSI ephemeral is, the API is different. Instead of specifying ephemeral, you specify CSI in the driver name, and it's kind of implicit that this is an ephemeral driver. So maybe what we can do is, if we like this API, in the future, before we go to GA, we can evolve CSI ephemeral to basically follow this API and become another option inside here. So instead of specifying volume claim template, you specify, the CSI inline ephemeral information as a separate struct. So it's either or. And that way,
Yeah.
as an end user, I have one entry point into ephemeral. I say, I want a persistent volume, which I do in a classic way, or I want an ephemeral volume, and that's done with this struct. And then I can customize either path by changing the
The volume discussed in this cap doesn't need to be CSI. It can be anything. It can be AWS, whatever.
I think that's fine. We just, because the name wouldn't be anything about CSI in this proposal here. If we just call it ephemeral volume source, then I get what Saad says, that we could have two optional fields where one of either must be provided but not both, and one would be the proposal here, and the other would be the information that we currently have for CSI volume source. I think that looks doable. We just need more discussions around the idea and whether we actually want to deprecate the current beta CSI volume source API and what that would imply. So for this, I would start with ephemeral volume source as defined here. I will make this a pointer. Perhaps I need to make it a pointer. I'm not sure. I might. That's the detail. If we make it a pointer, but we don't need to change it later on again. Yeah, that probably makes sense, or even for the initial revision. I'm thinking out aloud here. Just sorry guys. And then we have a path towards unifying those two APIs.
Yeah, I just want to make sure we're not, like, all of this makes technical sense for us. It makes our lives easier as developers of Kubernetes and as storage vendors who are implementing CSI drivers, but I want to make sure we keep the user experience in focus as well. If we have two different ways, actually 3 different ways to do ephemeral, users should be able to quickly understand them and not be confused. That should be our goal.
Yep. Okay, my screen somehow just went blank over the browser window where I was showing the cap. Oh, no, it's actually the Zoom window, I think. So I'm not sure whether you can still see something.
We can't see it anymore.
Yeah, it's just blank for me too.
Yeah.
We're also almost over with the meeting. I think I do have some ARs. The deadline is next Tuesday.
So can you send out an email to us when you've updated the caps, and then we can start reviewing them offline?
Yeah, I'll do that. Or I'll just separate email, or do you want to be pinged on Slack or GitHub?
I prefer email, but I think Slack would work fine. That's no problem.
Yeah. Okay. Okay. Yeah, unfortunately, I'll be out tomorrow. I do have oral surgery. I don't know how quickly I'll recover, so that puts a small uncertainty into the next few days. Perhaps I'll get something done today still.
Okay, take care. Hope you have a speedy recovery.
Yeah. Well, it's just a matter of how painful it will be. Shouldn't be. It's not risky. It's just awful, but needs to be done. So, thanks. And I guess I'm done. We still have 5 minutes left, but I don't think it's worthwhile going over anything else, right?
I have one random question. Do we know how this interacts with pod security policy?
Jan actually suggested that this will just work straightforward by if we add a new entry in the definition of what can be listed in a pod security policy, then the existing mechanism should either allow or prevent that. I still need to look into how that will work in detail, but I think it should be. It sounds like it will be straightforward.
Okay, and then this, since it's using PVCs, this means it will also work with storage class quota as well.
Yes, Jan also pointed out that this continues to work using the normal mechanism. Yeah.
Cool.
Any other questions? No, good. Then I guess I'll go and have dinner now. Thanks, everyone. I think we made some progress. Thanks. Goodbye.
Take care. Bye.
Bye.
Bye.